a PC or laptop which have Windows. Okay. So then click on the web interference, double click actually, double click on this. So you'll get a option like this. So we have four options here. YFs, interference, slit and diffraction. We have to open the slit option. So double click on it. Okay. So this is our software. So we have different option here. So you see right corner, there is a yellow color button. So this is actually the measuring tape. So we can measure the we have to measure the different value in nanometers, like source to screen distance, then slit separation, the distance between successive frames as well. So we can use this one to measure this parameter. So here is different wavelength. So we can see here different color. When you click on the, you see here three different source. One is water, and another is sound. The middle one is sound. The first one is water, and the third one is laser light. So you have to click on the laser light first. Then you see the different colors of violet, blue, cyan, and green and red, yellow and red. Okay. So we're going to determine the wavelength of blue, the green and red only. So we already in green position, and as you need two slit for the for the double slit experiment, so you have to sense this one in double slit. I mean two slit. Okay, so send it to two slit. So and the slit with the first one we will use the default one, the 500 nanometer, the slit width. And the slit separation, we will use different slit separation. I mean, we will use two different slit separation. One is 1500, and another one we will use that is 2100. Okay. So firstly, we will use the default one, 500 nanometer and 1500 nanometer slit separation. Okay. So we have to add some few option in the software, like we have to add the screen and then intensity graph. Okay. So after doing that, we have to turn on the light source. So the green button, this is the light source. If you click on it, then the not spherical, this is actually a plane wave, right? So plane wave will produce. So which will pass through these two slit, producing the spherical wave. These spherical waves are superimposed with each other and produce interference pattern. You see three interference fins on the screen, right? So let's have a look on the manual first, what we have to do here. Okay, so this is the experiment name. We have already shared it, right? Shared with all students. So the experiment name, So the VL means the virtual lab. One is O for optics, and the name of the experiment is determination of the wavelength of monochromatic light by Young's double slit experiment. So you don't need to write the objective and the system requirement and advice. So you don't need to write this thing in your lab report. So you have to write the um, lab report, right? So you have to start from your theory. So theory is very small here, not very um, long theory. So it's very small. So this is our working formula. We'll use it. So you know the lambda is the wavelength of light, and you are very well known about this experiment, right? So lambda is the lambda is the wavelength of light. Beta here the successive distance between two fringe, interference fringe, and D is the slit width. Um, and then the capital D is the distance between the slit and the slit and skin. Or so we have to determine these three parameters from our software. These are the working procedures, so you have to write the working procedure as well, but you don't need to draw the figure number 2 and figure number 3. Okay, so you don't need to draw it. So this is our experimental data table. So use only D1 and D2. We'll use two separate slit separation and measure the corresponding beta 1, beta 2. Uh, okay, so we only use the D1 and D2, not the D3. Okay, so we'll use two different D value, small D value, and for these two small D value, you have to calculate. You have to measure the beta 1 and beta 2, and then calculate the lambda 1 and lambda 2. Okay. So for the first one, for the measurement of D1, so the D1 is like, let's open the software. So here is the software. Okay. So so for the slit width for the first one is 500. So you have to write the right here D1. D1 is 500. So you can write here 500 nanometer. Okay. Okay. And the slit separation is 1500. The distance between the screen and no. Let me check. The slit width is one. So slit separation 1500, right? Slit separation 1500. 1500. Sorry. Um, the slit separation here 1500. So this is actually you have to measure from our software. So you can stop this software using this option. So click on it, then it will stop. Okay. So use the YOLO measuring tape and measure the values of capital D. Okay, from the slit to screen. So use your mouse, click on the plus sign, and then just drag it. Okay, up to the screen. So you see this is the value. So 2487.8. 2487.8. So write it here. 2487.8. Okay. So this is the D value. And for measuring the beta, use the measuring tape again. So you can measure from the fringe, from the middle of one fringe to the middle of another one, or or you can measure from the this uh, interference intensity graph. Okay, so it will be better if you measure from the intensity graph. That will be the correct one. Okay, so uh, it will be 939.6. 939.6. So you should write here 939.6. Okay. So now you have you got the D, beta, and capital D, right? So you can calculate the values of lambda. Okay. So this is the measure. This is the measure. Uh, and again you have to measure the capital D. So go to the software and just so resume it and then change it to 2100. The slip separation you have to change the slip separation to 2100. Okay. So there is so you see in the screen 1, 2, 3, 4, 5. So there are 5 interference fringe. Okay. Ah, power of variation.
শেষ অন ক্লাস করো এখন
সেটাই।
তোমার কথা এখন কেউ শুনতে পাবে না হ্যাঁ এখানে ভয়েসে কথা বলো
স্যার আপনাকে তো শোনা যাচ্ছে না।
Student, can you hear me?
Yes, sir.
Okay, so the problem with the headphone. Okay, so let's start again. So now you have to measure the, so you have to change the,
Your screen is not visible now.
okay, screen is not visible.
এখন দেখা যাচ্ছে।
Okay, so okay, so you have to change the slit separation at 2100 nanometer. We have already changed it. Okay. Now you have to measure again the parameters. So so the d value is same, but you have to measure the values of lambda. Okay, so this is peak to peak distance. So measure the beta again here. So it is 660.3. Okay, 660.3. So right here 66. Not here, right? So this one is 2100. So this one 2100. And this one 660.3. 660.3. Okay. This value is 660.3. Okay, so now you can calculate the values of lambda 1, lambda 2, and then make it average, okay? So you will get the values of lambda. And for measured value, so for measuring, this is actually the standard value. So how you can determine, so just click on the graph option, okay? Click on the graph option and then stop this software using this button here. So click on it and then use this measuring tape again. So you know the wavelength is peak to peak distance here. This is the wavelength. So it is the standard value is 523.5. The standard value is 523.5. So this is actually 523.5. So this is standard value. Then you can calculate the percentage of error using your observed value and the measure value. Okay. So these are the procedure for you have to use to calculate the values of lambda. Okay. For red light, you have to change this option, or you just move this one. So just click on the right button of your mouse and then just move it, okay, or drag it to anywhere of the red region. So you can set anywhere of the red region, okay. and then turn off the power source. But before doing this, you should click on here to resume. Okay, so click on it. Then you see the red spherical wave. Okay, and you'll observe the fringe as well. So for the red one, you have to start from 1500 first. So you should take the reading for 1500, and then when you finish with 1500, then change this value to 2100. Okay, similar procedure of green. Okay, so this is the procedure you have to follow. Okay, so do you have any question or any problem with the opening of software, student?
Please respond, anyone? Do you
স্যার
have any
একটু
problem?
ওভারঅল রিক্যাপ করা যাবে?
Overall recap, মানে how it is done?
Yes, ma'am.
Okay, so you want me to repeat again? Okay, so let's start with the red one. Okay, so the slit width is 500, and then slit separation 1500. Okay, so you observe 3 interference fringe on the screen. So you have to measure the distance between slit and the screen. Okay, slit and the screen, the capital D, and the values of beta. This is actually the successive distance from middle of the one fringe to middle of the another fringe. So you can measure from here, but I recommend you to measure from the intensity graph. Okay, so use just this measuring tape. So put on here the plus sign, and then click on the plus sign of here, and then drag it. Okay, using your mouse, the right not the right one, the left button of your mouse. Okay, so just drag it, so you'll get the values of beta. So this is actually 1180.3. So where you have to write, so put in your table is here. So this is 1180.3. 1180.3. Okay. And no, this is not the D, right? So this is actually the fringe width. So put it here. And for slit separation, the small d is again 15. So we are using 15, right? And the distance between the screen and the slit is same. So use the previous one. Okay. So 24. This is actually 2487. 2487.8. Okay. So you can measure the lambda. And then next one, you just change the slit separation to 100. Okay. So go to here and you can use your left button of your mouse, or you can click on the right arrow to change this value. Okay. So just click and make it 2100. So this is 2100, okay? Now you'll see the 5 fringes on your skin. So 1, 2, 3, 4, 5. Then measure the values of beta again using the measuring tape. So this is your value. Okay. So 877.5. Okay. 877.5. So this is beta. 877.5. So this is your beta. So this is 2100, right? 2100. And then calculate just lambda 2, okay? And for measuring the values of standard lambda for red color, so just stop this software using this button here, and then use the measuring tape again. So put it on the one peak and then move this one using your mouse here. So this is this value is 670.8. 670.8. So 670.8. So this is the wavelength of red light. Okay. So this is the procedure. It's very simple procedure. Okay. Any question? Any more question?
Sir, to calculate the beta, I mean, like take the beta on the graph, do we just take random points or is there like a specific
Oh, you
way
don't
to
need.
specify a point?
Oh, calculate the beta. Okay. So you can. So you want to calculate the beta, right? So you can use any peak to peak distance. Okay. So just stop it, and then I measure from here, right? From here to here. You can measure from here as well. So this is actually peak to peak distance. So you can measure from here, or you can measure from here as well. Okay, the same.
Okay,
Okay,
sir.
because right, the width of the interference fringe is same, right? The bright one and dark one, the width is same. Not, but in case of diffraction, this is not same. But for interference, the width of the interference fringe is same. So you can measure from anywhere, any peak to peak distance.
Okay, sir.
Okay. Any more question? You can practice, right? You can practice now for a few minutes. If you want, then you can practice. Just open the software and then practice it. Okay, do you want to practice now, or you can do it later, right? And then perform the experiment by yourself and then submit your lab report, okay? What do you want to do? You want to practice now, or you want to do it later? And any problem with the software? Is
Sir,
there
I'm
any
unable
problem?
to open the zip file.
So you have so you using the laptop or desktop computer?
Laptop.
Okay, so do you have the Windows operating system in your laptop or
Mac, sir.
no, it's not possible with Mac. It is not possible to open the software with Mac, okay, or Linux. So you need a PC with Windows operating system, okay?
Yes, sir.
Okay, I think we can now discuss about how to write the lab report.
Okay.
So this is the same as previous. You have already performed the experiments and how you have written the lab reports for the offline classes. Okay, so this will be same, but don't type the lab report. You have to write it with your hand as well, like previously. Okay, and draw the pictures. So for those two pictures which are showing the Young's double slit experiment, that the slit separation with the screen, that picture, okay, from the manual, that is given to you, and also write the theory and procedure. This figure, yeah, the figure number 1. You can draw this figure, okay. So then you can write the same way theory, then the procedure, then the figure and the table. Okay, you can individually do the experiment and fill up the table. This is not a group work, okay. Everyone can do on their own device and they can put the values from their data, okay. So then they can do their own calculation. It's not a group work, okay, it is an individual work. You will do it separately. And in the next class you are going to submit the lab report that you have performed on the previous day, and this lab report you can submit on your last day when you are going to give the viva. Okay, your next class will be on the next Monday. Then you will perform your last experiment. Then you will have 5 experiments done by then, and after that, then on the next week you are going to sit for the viva. So during the viva you will bring this lab report. So total you will be submitting 6 lab reports, 5 offline and 1 online. That is for today's class. Okay, so on that day about the viva we will talk in our next classes. Okay, next Monday and after that next Monday, those 2 classes we're going to talk about the viva for the odd and even sections. And during the
Ma'am,
viva you're going to bring the lab report. Takia, hey.
ma'am, for section 1, we still have 2 experiments left.
Section 1, 2 so next Monday will be for section 1.
Yes, ma'am.
Yeah, your class is on Monday.
Yes, ma'am, this Monday.
Yeah, this Monday, and after that Monday you have another class.
Oh, okay, ma'am.
Okay, we have the full February month left, right? And the exam is on 9th March. So we have many more classes still. Okay, no problem. We'll discuss
Okay,
about the
ma'am.
viva in our offline classes. So that will be better. So in the online, now we cannot explain that elaborately. Okay. So during that offline class, we will discuss more.
Okay, ma'am.
Okay, just to let you know when you are going to submit the lab report, that's why I'm talking about the viva. But actually, we are going to talk about this in our next class offline. Okay.
Okay, ma'am.
Okay, if you have any more question, you can ask. I think they don't have any questions, sir.
Okay, then if you don't have any question, then we can we finish from our end? Even
Yes, ma'am.
you can practice and then you can ask any question. If you have any question, then you can ask us in the next class as well, or the following class. Okay. So we'll be with you this month, right? So you can ask any question later as well. So if you want, we can stay for a few minutes or for practice. But if you confident, you are able to perform the experiment, then we can finish here. What do you want? We can finish, or if you want to
So we
practice.
can finish here, sir.
I think they're not responding.
So we can finish here, sir.
Okay, we can
finish
finish here then. Fahmi, you want to call them or for attendance?
I'm just taking from the participant list. I'm writing down their IDs from there, and then I will call if who are absent in my list. I will call them. Okay, I'm just first taking their IDs from the participant list. 2, 52, 54. So Imran Mobarez. Imran Mobarez. What is your ID? আচ্ছা স্যার কল করতে হবে হচ্ছে না চেঞ্জ হয়ে গেছে সব কল করছি আচ্ছা I'm calling, okay? I'm calling the roll numbers. You'll respond, okay? 102. Turn your microphone on. 102, হ্যাঁ 104. 6 আছো 6 তো ছিল আমি তো দেখলাম পার্টিসিপেন্ট লিস্টে 6106 108
Present, ma'am.
110
Present, ma'am.
112
Present, miss.
14 ছিল আমি দেখলাম তো 16
Present, miss.
16 18
Present, ma'am.
20
Present, ma'am.
22 24
Yes, miss.
26
Present, ma'am.
28
Present, ma'am.
30
Present, ma'am.
32
Present, miss.
38